So you are going to group these. With 3 and 4, this was a little bit different, so it's stretching you a little. Remember I said the first thing you need to do is look for a common factor, so something that comes out of all of them. So these actually had a common factor. So before you group them, you could take a 4 out of number 3, and then you could take an 8 out of number 4. And so before you ever start grouping them into pairs, you want to see, is there anything that comes out of all of them? So you may have started with 2, and then you could see that another 2 could come out. But for number 3 here, you want to take the 4 out first. All right. And then when you do that, just divide this. So you're going to get 56b cubed there plus 7b squared So once you pull out your common factor, then you want to factor by grouping. And so then you're going to do your grouping here. Leave that common factor out. Factor out your common factors there. 7b squared will come out of both of those. You're left with 8b plus 1. 3 will come out of both of those. You're left with 8b plus 1. And then when you put it into final factored form, you have the 4, which is where you get this 4. You have the 8b plus 1, which is what they have in common. And then what you have left over is 7b squared plus 3. So anytime you see huge numbers like that, you probably want to start by looking for a common factor. And that would have been exactly what you would have done for 4. You would have taken out the 8 first and then done your factoring from there. So you'll notice the difference between this and what we've been doing in the first couple sections is that this has a leading coefficient that is not a 1. So in all the other ones that we've done, if you recall, we had something like maybe x squared minus 5x plus 6. For something like this, you only have to worry about this last term because the first 2 terms are 1 and 1, 1x, 1x, right? And so we don't really have to worry about anything that's happening with this because the coefficient is just 1. And when you multiply anything by 1, it doesn't affect it. We only had to worry about factors of 6. 1 and 6, 2 and 3, specifically that add up to get -5, -2, -3. They add to give me -5, they multiply to give me +6, right? But when you throw in something like this, where we have a leading coefficient, then all of a sudden you'll notice my first 2 terms are not just x and x, because I don't need x squared now, I need 3x squared. All right. And so when you end up with a trinomial that has a leading coefficient of something other than 1, you have to then consider how that is going to affect not only your first term, but also your middle terms. All right. Because what happens is this becomes the sum of your inner and outer terms. If I take 3 and 5, I get that 15x. -2 and 1x give me my -2x. And all of a sudden, we don't have to just worry about factors of 10. We also have to worry about how that affects the middle term because of those factors of 3. And so then you start looking and see, how am I going to pair this up to get this particular problem? And so what you can end up doing, and you can kind of see it here, if this were a 10, what you end up doing with these is you actually split this guy up first and you factor by grouping. That's how we're going to do it. I'm going to show you both ways, but we're going to do it in a method where you can then split it up into 4 terms and then just factor by grouping. And then all of a sudden it makes it a little bit easier and you don't have to try to be pairing up all of your factors of 3 and all of your factors of 10 to see which pairs give you the right one, because then you start getting to a lot of combinations if they have a lot of factors. So let's look at this first example. They want us to factor 3x squared plus 7x plus 2, all right? And so when we look at this, we have to consider the fact that we have factors of 3 and factors of 2 that are going to affect this 7. Because if I were just to look at the 2, are there any factors of 2 that add up to give me 7? Well, no, the only factors of 2 are 1 and 2. So the very most I can add up would be 3, right? And so now we have to think about the fact, well, 3 is going to make a difference. So the easiest method to do this, I don't know what they're called. Sometimes they call it a rainbow method because you draw a cross. Call it what you want to call it, but this is the process, all right? So what you're actually going to do is you are going to take this 3 and you are going to multiply it by this 2. So your very first step is to multiply the leading coefficient and the constant. So we're going to say 3 times 2. All right? 3 times 2 is 6. Now what we're going to do is we are going to look for factors of 6 that add, because we got a positive 6, a positive 3, and a positive 2. So they are either going to be 2 positives or 2 negatives that add up to give us 7. In this case, is it going to be 2 positives or 2 negatives? Positives, because we need a positive 7. What factors of 6 add up to give me a positive 7?
6 and 1.
Yeah, 6 and 1. All right. And so that's what we're going to do. We are going to rewrite this trinomial into a 4-term. This is the way we do it. We leave the first term alone, 3x squared. We leave the last term alone, plus 2. All right? We are going to split up the middle term using these factors. So instead of 7x, we're going to write a positive 6x and a positive 1x. Does everybody see how this 4-term equals this 3-term? Right? So if I were to combine these terms, I would get this. All right, I have not changed it. I've just rewritten it. Now I have a 4-term, and I am going to factor by grouping. So just what you did for bell work, we're going to factor by grouping. We're going to group the first 2, and we're going to group the second 2. All right, so what can I take out of the 3 and the 6? What number is in common?
3.
What variable can I take out? And I'm left with 3 divided by 3 is 1, and I have 1x left over. 6 divided by 3 is 2, and I have no x's left over. Can I take anything out of the second group? No. So when I cannot take anything out, what number always comes out?
1.
A 1. And I'm left with x plus 2. And then how do I finish it? Well, my x plus 2 is what I have in common. X plus 2. My leftover is 3x plus 1. 3x plus 1. And that is my factoring. Now here's the thing. You will get to where you can potentially do this without doing factor by grouping, especially when it's 2 primes. So 3 and 2. I know that my factors of 3 are 1 and 3, and I know that my factors of 2 are 1 and 2. I need to figure out how those will multiply to give me my 7. So if I look at this, I'm going to say, well, 1 times 1 and 3 times 2. That's going to give me 7. What gets confusing here is I know I need to pair up the 1 and the 1, and I know I need to pair up the 3 and the 2. But they actually end up in opposite groups. So my 1 and my 1 ended up here. My 2 and my 3 ended up here. And so there is a method to just group them accordingly. But that method gets a little tricky when you have a lot of factors. Like I only had 4 factors and it's a little confusing. I had 1, 3, 1, and 2. And just figuring out what order they go in is very confusing. Imagine if you had like 4 factors for this guy and 4 factors for this guy. Think of all the pairs you could do, what groups you could do together. Lots of groups happening when you start pairing them up different ways. And so the grouping method works every single time and it ends up being a little bit easier. So this is why we do this method. If you look at the bottom of this page, 415, it actually walks you through this method. It says factoring trinomials. Find factors of A and C whose sum is B, right? The first and the last. Rewrite the middle term as a sum of terms with these factors. Factor the 4-term by grouping and then check by multiplying. All right, so it's telling you multiply across, find your factors, rewrite it to 4-term, and factor by grouping. That's what we're going to do. So let's do another one of these. All right. So we are going to multiply across. We're going to say 2 times 24. 2 times 24 gives us what? 48. All right. So now we need factors of 48. Specifically, it was a positive 2 and a positive 24. This is positive 48. That means my factors have to be either positive, positive, or negative, negative, right? And what do I need them to add up to? I need them to add up to negative 19. So that means I'm going to do negative, negative, right? So what two factors of 48 add up to give me 19? You can list them. So if you don't know, you can do this. 1 and 48, 2 and 24, 3, 16, 4, 12. Yeah, 3 and 16, right? Everybody see that? So if you don't know, just start listing. 1 times 48 is 48. 2 times 24 is 48. 3 times 16 is 48. 4 times 12 is 48. So you see what I'm doing there? 8 and 6 would have been my next one, 6 and 8, right? And so if you don't automatically see it, just start listing your pairs that multiply to give you 48. And then you'll notice, okay, these two add up, right? So I'm going to rewrite this guy. I'm going to leave my first one alone, 2x squared. I'm going to leave my plus 24 alone. All right. And then I am going to use, these factors in the middle with an x, right? So negative 3x, negative 16x. I have just rewritten it into a 4-term. And now I'm going to factor by grouping. Group here, group here. What happens when I group behind that right there? Yeah, the last one changes to the opposite. It was a positive, it needs to be a negative. All right, what can come out of my first group between 2x squared and 3x? What can come out? Just an x. I'm left with 2x minus 3. Between 16 and 24, what can come out? An 8. I'm left with 2x minus 3. My final factoring, I'm going to take that group out. I'm going to be left with this group right here. All right. I can always check it by foiling. So you can say 2x and x is 2x squared. 2x and negative 8 is negative 16x. Negative 3 and x is negative 3x. Negative 3 and negative 8 is positive 24. When I combine those, 2x squared minus 19x plus 24. And that is correct. All right, what do you notice about example 3? So in order to start this factoring, we need to make sure it's in standard form. You need to rewrite it. So I'm going to rewrite the standard form before I do anything else. The x squared is going to go first, then the x. Whatever sign is in front follows it. So this is a negative 7x. It will be a negative 7x here. This is a negative 20 or a minus 20. That will go there. All right. So before I ever start, I need to make sure that this is in standard form. All right. Now I am going to do the same method. I'm going to multiply across 3 times 20. So 3 times the negative 20 is negative 60. I need factors that will multiply to give me negative 60 and add to give me a negative 7. So again, if you don't know, just go through them. 1 and 60, 2 and 30. They are going to be subtracting, right? Because one's going to be positive and one's going to be negative, right? 3 and 20, 4 and 15, 5 and 12. You see anything that subtracts to give you 7?
12.
Yeah. 5 and 12 are going to subtract to give me 7. Specifically, I need a negative 7, all right? So this is the pair I'm going to use, but specifically one is going to be positive and one is going to be negative, and I need a negative 7. So which is which? So I'm going to look at this sign and say the larger factor is going to be whatever sign this is if I have two different signs. So that means my 5 is positive and my 12 is negative. You can double check this before you start this process. Do positive 5 and negative 12 multiply to give me negative 60? Yes. Do positive 5 and negative 12 add to give me negative 7? Yes, those are my two factors, all right? And now I'm going to rewrite and factor by grouping. So I'm going to say 3x squared plus 5x minus 12x minus 20. Factor by grouping. So that just means group the first two, group the second two. I grouped behind a negative sign. So what do I need to do to that 20? Yeah, change it to a positive. I grouped behind a negative. I need to change the last sign, all right? And then I'm going to look at them individually. What can I take out of 3x squared and 5x? So I have 3x plus 5. What can I take out of 12x and 20?
3, 4.
A 4. And I'm left with 3x plus 5. All right? My final step here is to take out my 3x plus 5. What's left over is my second group, x minus 4. And again, you can FOIL to see if you did your factoring correctly. So my first step in factoring we always build up to it in the sections, but really when you're looking at factoring, your very first step is to look for a common factor, always. You always want to see if there's a common factor before you start doing this. First of all, I do not want to multiply 12 and 10 and then look for factors of 120. All right, so for starters, you're going to have huge numbers if you don't look for these, okay? The other problem here is I have an x cubed, which is an issue if I am multiplying, right? I'm going to have an x and an x squared, and then this is going to be very confusing. And so at this level, I'm not going to give you something like this to factor unless you likely have a common factor to pull out, okay? So before I ever start, I am going to look at the 12x cubed, the 26x squared, and the 10x and say, what do I have in common for all three of these that I can take out? 2 and an x, right? So I can take 2x out before I ever start. And then I'm left with 6x squared minus 13x plus 5. Much better when I start to multiply across and figure out what I'm looking for. So now we're going to leave the 2x on the outside. Just leave him alone. He's going to be part of your final answer. Now we're going to do the inside the way we've been doing it. So we're going to say 6 times 5. 6 times 5 gives me a 30. Because this is a positive 30, I'm going to either have plus plus or minus minus. Which will it be? Yeah, both subtraction because I have a negative 13. So I need factors of 30 that add up to give me 13. What is it? Yeah, 3 and 10. Specifically, -3 and -10. I can double check this before I break it up. I want to say -3 plus -10. Does that give me -13? Yes. -3 times -10. Does that give me +30? Yes, these are my correct factors. So now I'm going to rewrite it. I'm going to leave the 2x alone. You'll notice I do brackets because I'm about to group it. I'm going to rewrite it. 6x squared minus 3x minus 10x plus 5. We're just rewriting this term right here. And now I'm going to factor by grouping. Group the first two, group the second two. I grouped behind a negative. I'm going to change that sign. 2x comes down again. Look at my first group. What do I have in common? 3x. I'm left with 2x minus 1. Second group, what do I have in common? 5. I'm left with 2x minus 1. And then my final step is to do all of my factoring. This will go first, 2x. Then I'm going to... So this is my group that I have in common. This is the group that I have left over. And that is all my factoring. You'll notice we have an x and a y. You can really actually somewhat ignore them a little bit when it comes to the numbers. We are looking for factors the same way we would. So if you're going to include it when you rewrite it and group it, but you don't have to let it throw you off because we have an x squared here, we have a y squared here, we have an xy here. As long as that's the case, we should be able to factor it. So we're going to go straight to the numbers. We are going to multiply the 2 and the -14. So 2 times -14, that gives us -28. I'm looking for factors of 28, one positive and one negative. That will give me a 3. What are they? Any takers? There we go. So which one's positive and which one's negative? Of my 4 and 7, I need a +3. This one's negative, this one's positive, right? It will always follow the larger. So this is what I'm going to use. When I rewrite it, leave this one alone, 2x squared. I'm going to use the coefficients I just got. -4, but I need an xy. +7, I need an xy. All right, and then -14y squared. All right, so now my middle term has both variables because I need an xy in them. All right, so we're going to just factor by grouping, but now you're going to notice we have variables that come out of each group. All right, so out of this first group, I can now take a 2 and an x, and I'm left with x minus 2y. For this second one, I can take a 7 and a y, and I'm left with x minus 2y. Then I'm going to do exactly the same. My group in common is x minus 2y. My leftover group is 2x plus 7y. And I am done with my factoring.